right. We are recording this lesson as of right now. Okay. So, as I was saying, you need to get out a piece of paper. All right, we're going to set up that piece of paper like we set up our notes. Today you are taking your own notes. So make sure that you have your paper out so that you don't get behind. All right, so at the top, please make sure you write your name. I'm writing name. Please do not write name. Please put your name. Okay? Today's date. If you have something to say, I need us to raise our hand, okay? Let's participate appropriately, please. All right, so we have 9/5/18 as the date. We did say this is number 9, so everything today will stay together. Our notes are number 9. Our homework is number 9, so we know those go together. All right, the first thing we're going to add today, we're going to add another vocabulary word. All right, so we've been talking about vocabulary a lot for the past 2 days. Yesterday we talked about vocabulary. We had 2 words. Today we're adding another word. The important thing that we mentioned about vocabulary is for your test. The test that's next Friday. This Friday is a quiz, but the test that's next Friday will have vocabulary on it. All right, the test that's next Friday will have vocabulary. All right, on that vocabulary, will you get a word bank? No. No. Will it be matching? No. It will be fill in the blank. And just to show you, I made the test this morning. All right, this morning, I typed up the test. That is somewhere over here. And when...
Turn on the bell.
When I made the test, guys, this is the second page. Here's the second page of your test. Do you see any word bank?
No.
Do you see any matching?
Yes.
No. You just see a blank, and in that blank you have to write the word. All right? Do I care if you spell it correctly?
Yes.
Yes, guys, it's 5 words. Part of being in school is becoming more educated, and part of being educated is being able to spell. All right? So I do want you to be able to spell these 4 words. 5 words. I'm sorry, there are 5 words on there. You got 2 yesterday. So raise your hand if you can tell me what is the value where the digit is located in a number. What is the value where a digit is located in a number? Evan? Place value. What is a number with a point separating the part that is greater than 1 and the part that is less than 1? Maddie? A decimal. And then today we're going to add the word algorithm. Raise your hand if you've heard the word algorithm. I should see everyone's hand up in the air. Thank you. Good job, guys. All right. We talked about algorithms for those first 2 weeks of school when we were going back over adding, subtracting, multiplying, and dividing. Raise your hand if you can tell me, what do you think an algorithm is in your own words? Jay? Okay, say that again.
The order of something.
The order of something. The order of what? Juan Carlos?
The way you do something.
The way you do something. Specifically, the way you do what? Math. All right. So that's basically what we're going to write down here for our definition. An algorithm is a process, which is a way of doing something. A process to be followed, which is a fancy way of saying how you do something. A process to be followed in calculation, which is where that math comes in at. All right, so an algorithm is a process to be followed in calculation. Right now, if I told you that, I imagine that some of y'all could guess algorithm because we've talked about it so much in the first 2 weeks. If not, there you go. There's our definition. All right, got it right off the test, so make sure you know that definition. All right, multiplying decimals. That's our goal today, is to multiply decimals. So multiplying decimals. All right, number 1 rule for adding and subtracting is kind of like the number 1 rule, but the opposite way for multiplying. When we add and subtract, we want to line them up. When we multiply, we do not line up the decimals. And we're writing that in. Do not line up the decimals. Now, if they happen to line up, that's okay, but we don't want to try to force them to line up. Yes, Jay?
I know why.
Why?
Because if you don't multiply decimal, you let your decimal move.
Yeah, we're going to talk about that. Very good. All right. So, guys, this should be reviewed from 5th grade. All right, we're just going to go over it again in detail. We're going to do one example where we're going to write out our steps with a lot of detail, and then we'll do 2 more just to make sure we look at some special cases that could happen, and then you'll get your homework to do for the rest of the class and finish it up. All right. So we're going to do 9.7 times 1.58. If we could stop clicking our pen, I'd really appreciate it. Thank you. All right, when we do multiplication, I know a lot of us have already realized that in multiplication we can pick the order, and sometimes the order that you pick can make a problem easier or harder. So in this problem, that's going to come into play. In this problem, when I set it up, how could I set it up to where it's easier? What could I do to set it up easier, Ryan?
It's the number that's longer on top.
Excellent. So excellent as well. I want to mention real quick what Ryan said and then what Anderson added to that, because those are the wording there was amazing. All right, so I like it. We were very particular with the words that they chose, okay? So Ryan said 1.58 is longer, so she wants to put it on top. You notice she did not say 1.58 is bigger, because is it bigger than 9.7? No. But 1.58 is definitely not bigger than 9.7, okay? That whole number is much larger. But she said that it is longer. That's an excellent thing to say. All right, I like that wording that we chose. And Anderson said another way of putting that is that it has more digits. All right, 1.58 has more numbers involved. Okay, so we're going to put a little dot here, a little bullet mark. And we're going to make sure we specify that we always want to place the longer, all right, or the number with more digits. Longer is just less writing. So the longer number on top. I'm going to place the longer number on top. So when we set this up, guys, we already said that the number 1 rule is to not line up the decimals. Some of y'all might have seen this last year. It's possible to do this problem without any decimals until the end. So when I set this up, I'm going to put my 1.58 on top, like Ryan said, but I'm not going to put that decimal in until the very end. And then on the bottom, I'm going to put my 9.7, lining up the numbers, but again, without the decimal. All right? Now, guys, I would suggest this because this is going to be helpful when we take our test. You'll have adding, subtracting, multiplying, and dividing. For the quiz Friday, you'll have add, subtract, and multiply. And they'll be mixed together. If you get in a habit of lining up the decimals for adding and subtracting, if you're still writing the decimals for multiply, what are you going to be tempted to do? You're going to be tempted to line them up. So if we'll leave them off till the end, we kind of help to break that temptation. Does that make sense? All right, it's just a strategy. You can write them if you want. We don't need them, though. All right, so let's multiply. When we multiply, we're going to use the standard algorithm. So we're going to write multiply using the standard algorithm. So this is the way we've been multiplying since the beginning of the year. You know, multiplied like this in the 5th grade. All right, multiply using the standard algorithm. Everyone fill that in, and then we'll multiply together. So 7 times 8 is 56. So I'm going to write my 6. I'm going to carry my 5. 7 times 5 is 35. Don't forget to add the 5. My first 2 classes I forgot, and we had to fix it. So 7 times 5 is 35, plus 5 is
40.
40. Some of us have made that easy error, so be careful. 7 times 1 is? 7 plus 4? 11. And do y'all see how I'm spacing my numbers out? All right, again, that's just so it makes organizing my work easier. And then at the end, I can fit a decimal in between any of my numbers without trying to squeeze it in, okay? So now we're done with our 4 and our 5, done with our 7. So let's put our 0 as a placeholder. Now we're ready to multiply by 9. Don't forget your 0. 9 times 8? 72. Carry my 7. 9 times 5? 45 plus 7? 52. Good job, guys. And then 9 times 1? 9 plus 5? 14. All right. And we're going to add that up, just like with our standard algorithm if they were whole numbers. 6 plus 0? 2 plus 0? 1 and 2? 1 and 4? 1? All right, so now this is where we have to be careful. We don't want to think that our answer is 15,326. We do need to move our decimal over. So let's put our rule and then we'll do it together. So our next step, we want to move the decimal over the amount of times that there are digits behind the decimals in the problem. Okay, that was a lot. I'm going to give you a second to get that copy down, and then we'll talk about exactly what that means. Some of you already know, and you can go ahead and do it on your paper. If we're not sure, or if we just want to make sure, you can do it with me if you'll just wait patiently. Let's let everyone get that written in. All right, looks like a lot of our pencils are stopping or slowing down. All right, so I'm going to read it again. It says, move the decimal over the amount of times that there are digits behind the decimals in the problem. So first, let's look at the problem. Here's my problem. How many digits were behind the decimal in the problem? Cameron? 3. So we have 7's behind, 5's behind, and 8's behind. So that gives me 3 digits behind the decimal. Do y'all agree? All right. Now the front part of this says move the decimal over that many times. So when we're saying to move it over, the decimal is going to start at the very end of the number. So everyone put your pencil at the end. And then we said there were 3 digits, so we're going to count over. 1, 2, 3. And that's where our decimal is going to go. All right? Here's something else that we can use to double check. How many numbers were behind the decimal in my problem? 1, 2, 3. How many are behind the decimal in my answer? 1, 2, 3. That's just a good way to double check and make sure you moved it over correctly. All right, are there any questions about that first problem that we did? I know it was kind of slow. Y'all ready to speed up a little bit? Okay, we're going to do a couple more. All right.
I'm ready to fast. I'm ready to fast.
All right, guys, we're not going to go fast and leave anyone behind. All right, number 1. If you want to work ahead, you can, as long as you're checking your answer as we go through it together. All right, so we have 0.007 times, better, 0.007 times 13.95, and then number 2 that we're going to do. Is going to be 0.61 times 798. All right. on number 1, we've talked about how we want to use the longer number on top. But on number 1, you'll notice both of them have 4 digits, correct? So we still can make a good choice here. What would probably still be the easiest one to put on top? Kaya? 1395, because that's the biggest number. Not the biggest. Well, it is the biggest. But it's also the hardest one, correct? So the one that you don't want to have to multiply by a lot, that's the one we want to put on top. So I'm going to put 1395 on top. Again, I'm leaving that decimal off because I don't need it until the end. All right, times, I'm going to put my 7, it's at the end, so I'm lining it up with the 5 that's at the end. And then there were 3 zeros in front, 1, 2, 3. All right, and we're going to multiply that out. Trying to make sure that I still have it so y'all can see. All right, 7 times 5, 35. Thank you. That was faster than I could get out of my mouth. All right, 7 times 9, 63 plus the 3, 66. 7 times 3, 21 plus the 6, 27. 7 times 1, 9 plus the 2.
9.
Oh, 7.
It's 7 times 1.
Oh, thank you. Thank you, Mr. Whiteout. Oh, I already had it up here. I already had my whiteout ready because I knew that sorry, I heard 9 and then I was adding 2 to 9. Some of y'all junked the gun on my questions. And I guess I wasn't paying attention. I'll take the blame too. Okay, so 7 times 1 is 7 plus the 2 is 9. Okay. So now we need to figure out how many times to move it over. So in this problem, 1, 2, 3, 4, 5. All right, are there any questions on where I'm getting 5 from?
No.
There's 1, 2, 3. 3 numbers in the first problem. 2 numbers in the second number. So that gives us 5, correct? All right, now there's only 4 numbers here, so let's see what happens. So I'm going to put my pin at the end, and I'm going to move over. 1, 2, 3, 4, 5. So there's where my decimal goes. What's happening here, Jacob?
You're adding 2 more zeros because you have to have placeholders for it, as you said.
Okay, so that's good. So y'all see where I have a gap here? All right, we do need a placeholder there. The number that we like to use for placeholders is 0. All right, we do have to add a 0 there because there was an empty gap. So we need that 0 to hold everything's place so that it doesn't change its place value. Okay? Now, some of you like to put a 0 in front. That's up to you. I am okay with us leaving it as 0.09765. Here's my stipulation. Please make sure that I can see that decimal. Make your decimals very bold. Because if you just put I'm going to put it up here. If I just put a dot, right, you can see the dot, but I might just think it's a stray mark, all right? If this is your decimal, it's not big enough. Your decimal should look more like this. Okay? Are we okay with that? All right, let's look at the next one. On number 2, what's going to be the best number to put on top? What number do we want to put on top? Holland.
61.
Thank you, Holland. Will you say that again for me? 798. All right, remember, we raise our hands for a reason, so I can hear the answers clearly. All right, so then I'm going to put times. I'm lining up my 1 at the end, then my 6, and then my 0. Am I worrying about the decimal right now?
No.
No. All right, so we're going to multiply our 1 times 8. And we get 8. 1 times 9. And we get 9. And then 1 times 7 is 7. All right, that one was a really good one to put on the bottom because it did have the 1. Here's my little tip, guys. If it has a bunch of zeros, that's probably going to be the one on the bottom. Because their 0 is easy to multiply by. Yes. And in fact, why didn't I multiply by these zeros? Because you're going to get just rows of zeros. Adding rows and rows of 0. Do they change anything?
No.
No. And I should have emphasized that then. So we're not going to add in all those rows of 0. Okay? So let's do 6 times 8. 48, carry my 4. 6 times 9.
You forgot the 0.
Woo, y'all, thank y'all. Way to be on top of things. Don't forget your placeholders. I'm okay with putting this on YouTube. I'm okay because here's the thing. We're all human. We all make mistakes, right? All right? As long as we're learning and growing from those mistakes, that's fine. Right?
Subscribe and turn on the bell. We maybe not want to turn on the bell, but subscribe.
All right. I would like to think that I can record any of my classes, but that behavior and discussion, that's not what's appropriate, okay? So let's keep it geared towards the math. All right? I like that we're keeping up with my mistakes, but when we go off on those kind of tangents, that's not what we need. All right? All right, so now we're going to keep going. Well, we're going to start all over since I messed up. So 6 times 8. 48. Write our 8. I've already put my 4 there since I made a mistake the first time. All right, 6 times 9. 54 plus that 4. 58. Carry my 5. 6 times 7. 42 plus the 5. 47. Okay? Now again, we could multiply that 0 times everything. I would just get a whole row of zeros. Does that change when I add stuff? No. So we're just going to go ahead and add these up. 8 plus 0? 9 plus 8? 17. Carry my 1. So that 1 and 7 gives me 8. Plus another 8.
16.
Carry the 1. 1 and 7?
8.
And then we have 4. All right? On this problem, my answer isn't 48,678. What do we still have to put in there, Maddie? The decimal. Thank you, Maddie, for raising your hand. All right? When I put my decimal in there, where is that going to go? Caden? I'm sorry, Evan? In between the 6 and the 7. So we only have 2 numbers after the decimal. Did 798 have any decimals? No, so we're only moving it 2 places. All right, so just like Evan said, between the 6 and the 7, so we get 486.78. All right, guys, I'm going to pass out our homework. Emil? Okay, so that's a really good question that Emil asked, and if we weren't too busy moving and talking, we would have heard it. You were asking, how does my answer get smaller? All right, so I want you to look at like number 2. We have 0.61. That's really small, right? What's happened is this number that's smaller than 1 has repeated 798 times. So that's like having half of something 798 times. Isn't that kind of close to half of that? So that's why our numbers, it looks like they're getting smaller, but it's because that decimal is so tiny, when it repeats, it's not going to give you a larger number. Does that make sense? All right. Aaron, you had a question?
How do you divide decimal?